Okay, in the last video, this was the state machine that we were considering. This effectively is our completed traffic light system. This incorporates now an SR latch, the output of the SR latch being this input to the state machine, SW. We also have incorporated a counter, which is providing a timeout feature for the people to actually cross the road. So when we move into this state over here, basically we're going to be in this particular state. It's a 4-bit counter we're using, so we're in this particular state for 16 clock periods. Once the carryout of the counter becomes a 1 on the next leading edge of the system clock, we then move into this state over here. We change the lights back to a red condition for the traffic, a white condition for the people. Once again, we clear the counter at this point. Then we move into this state where we've changed the condition for the traffic to be green, keeping the people waiting. We now remain in this state for 16 clock periods. Once the carryout becomes a 1 again, we move back over to our state here. We still have north, south, green, and wait. But in this state, we are now once again looking at the crossing switch condition. Okay, so that's the state diagram then of a realistic traffic light system. Over here, you can see the block diagram of that system. We have the SR latch configuration here with the push button. This is a normally open push button. So on pushing it, this guy closes. We have our state variable flip-flops over here, and then our counter sitting up over here. And then our various light conditions here, the clear of the counter, the reset provided by the state machine, our next state outputs. Okay, so the issue is then, we need to be thinking about the logic over here and how we actually implement that logic. Okay, this is the state table that we'd actually derived last time for the logic. And it's from this state table that we'll actually figure out Boolean equations, at least that's one way to go, and correspondingly the gates that we actually need. But before we do that, there are some unused states. Notice that we have what? 3 state variables, okay? Have we used all the states? No, we have not used all the states. There are a possibility of 8 different states, okay? We're up to state 101. What's left? Yes, look, we could have the state 110. We could also have the state 111. Now these 2 states here are not part of our normal sequence, and that's absolutely true. But it is possible that we could get into one of those unused states. There could be a power surge, some kind of a glitch, whatever that could cause us to actually end up in one of these unused states. So we should design for it. Okay, so what do we really want to happen if we are in one of these unused states? So this is the point that we're going to figure out what we should do. All right, so let's look at that. Well, let's look at the first case. The 110 state. Well, I don't really care about the switch. I don't really care about the carry out. So really, where should I go next? Well, I want to get back into normal sequence of perhaps operation. Yeah, that's a possibility for sure. We might want to do that. So our normal sequence of operation might be going back to the beginning again, perhaps. Yes, let's do that. 0, 0, 0 state. So on the next leading edge of the system clock, that's where we would go. What do we want to do with the lights, though, if we are in that state? Well, I reckon that we should really make sure that we stop the cars. So we'll have a 0 for the green, a 0 for the yellow, a 1 here for the red light. And we should stop the people as well, have a wait condition there, okay? So we're not activating the go, we're not doing a reset, and look, since clears are low acting, we're not clearing, okay? Well, if we're in the 111 state, once again, I don't care about the switch, I don't care about the clock or the carry out. Where do I want to go next? Perhaps the same as above. I'll go back to the 0, 0, 0 state. I'll make sure that basically I've stopped the traffic, I've stopped the people, and I'm not doing a reset and I'm not clearing. And so now we could say that that is our state table taking into account those two unused states. And it's something important, it's something you really should consider. So now what we need to do is design the logic. All right, various ways to do this. And the first way we're going to consider here is to actually look at coming up with some Boolean equations, and we'll look at a gate implementation. How do we do this? Well, we're going to take each one of these outputs in turn. We're simply going to come down the column and we're going to find out where the one terms occur. And each one of these one terms represents a product term, okay? We're going to write down those product terms and then we're going to simply sum them together. So that's what we're going to do now. Okay, let's see if we can write down a Boolean equation then for AN. All right, in a sum of products form. So AN is equal to, come on down the column, we hit the first one here, read off what that product term is. Don't care about SW, but we've got a carry out. So that's CO, that is what? A bar, and that is B, and that is C. Or, okay, come on down, there's another product term here. Again, I don't care about the switch or the carry out in this case, so that is what? A, and that's B bar, C bar. Or, we've got one more product term here, haven't we? It's this guy right here. So what is this? This is CO bar, that would be A, that would be B bar, and that would be C. So we've written down the Boolean equation now for AN. So while we're here, let's see if we can actually go ahead and minimize this, okay? Well, how would we do this? Well, look, we could use Boolean algebra to do this. Look, I think there are four variables that we're concerned with. That's CO, A, B, and C. So why don't we just use a four-variable K-map, all right? So I'm going to draw one in right here, and we'll see what we get, okay? So here we go. Four-variable K-map. Okay. All right. Now, let's look at the variables. Well, we'll look at CO, let's look at A, and then let's look at the BC. All right, let's look at values along here. 0, 0, 0, 1, 1, 1, 1, 0, and then, of course, this is 0, 0, 0, 1, 1, 1, 1, 0. Now, what we're going to do is plot that guy on here, and then let's see if we can actually minimize, okay? Let's take the first term. That's CO, A bar, B, C. All right, CO, A bar, B, C would be a product term existing right here. Next one, this is A, B bar, C bar. So where is A true? Okay, let's think about that. Well, A is true here, isn't it? And here. And then this is B bar, C bar. So it's really those two squares which are occupied. The last term over here, which is CO bar A, so CO bar A is here, and then we've got a B bar C, the B bar C is here. So really we've got another term that exists right here. All right, can we do much with that? Well, maybe not really a lot, there's a little bit we can do. So let's have a look at this. What are my groupings? Well, I can group those two together. Okay, and I can write down my expression then minimized. AN is equal to, looking at these two together, we've got what? CO bar A, and what's common here is just B bar, isn't it? So we've got a B bar sitting there. Or, well, I can certainly group these two here, and we've seen that before. So this is what? This is common this way is A, and then we've simply got B bar, C bar. So that's a B bar, C bar. We already had that term up there. And then finally, not much you can do with this guy over here. I can just write down that this is then CO. So that's CO, A bar, and then that's BC, which is that term right there. And that's the best we can do as far as minimization is concerned. Okay, now let's look at BN, all right? So here's Bn. Bn is equal to, all right, let's come on down, see what we've got. All right, first product term is right here, isn't it? Let's read it off. That's going to be what? That's A bar, that is B bar, and that is C. Or, next product term is right here, so what is this? This would be A bar, this is B, and this is C bar. Okay, and then we have what? Just one more product term, which is here, and this would be or CO bar, A bar, and that is what? BC. All right. Once again, let's see if we can actually minimize this. We'll draw a 4-variable map as we really did before. So let's just go ahead and do that. So here we go, our 4-variable map. Okay. All right, so here we are. As before, we'll call this COA, and then this would be BC. Value 00011110. This is 00011110. Let's plot this on the map. So what have we got? We've got A bar, B bar, C. Okay. So where is this? A bar, B bar, C. So there's A bar here and here. Okay. And let's see where C is actually true. Okay. Where is C true? Okay, so C is true right here, isn't it? Okay, so we've got a 1 sitting here, and of course we've got our 1 sitting over here like so. That's our first term plotted. Next term is what? A bar, B, C bar. Okay, so once again, there's the A bar. Okay, so basically A bar is true for this whole row here, A bar is true for this whole row here, but where is B, C bar true? So there's the B, there's the C bar, okay? And so really we have a term here and a term here. That's that guy plotted. Last one here, okay, that is what? CO bar. Well, CO bar is right here, A bar, and then BC. So we've got a 1 sitting there like so. All right, now let's see if we can actually minimize this. Well, yes, look, we can minimize here and here. If we write that down, we get Bn is equal to, and this is what we had before. So let's read that off again just as a practice here. What is this? A bar. So let's write down A bar. And then, of course, what do we have here? We have B bar C. So that's our B bar C term. Or, well, we can group this. We can group it with this. And then reading off again, we have A bar and we have B C bar. B, C bar. Or, well, yes, let's see what we can do here. Well, look, I could group this way, couldn't I? I could just group like this, and I could read that off, and I've got what? CO bar, A bar, and what is common here? Yes, it's just B, isn't it? And so, yes, a little bit of benefit from minimization. Not a lot, but just a little bit at this point. All right, let's look at Cn. So let's write this down. So Cn is equal to, our first product term here is what? Well, that's a SW, that's A bar, B bar, C bar. That's our first product term. There it is. Come on down. Next product term is here. Let's read this across. So that's an OR. What do we have here? That's A bar, B, C bar, okay? It's that product term. Next one is here. Let's read that guy off. Or, reading across, we have CO bar, A bar, B, C, okay? Next product term is here. So I'll go down a bit here. Or, what is this? This is just A, B bar, C bar. Okay, and we've got one more product term right here. So that's an OR, CO bar, and that is an A, B bar, and C. All right, so that's our Boolean equation then for Cn. All right, let's see if we can actually reduce our expression for Cn. Note there are 5 variables here, so we really have 2 4-variable maps. This guy is the SW equals 1 map. This is the SW equals 0 map. So let's plot each of these terms. Okay, first term over here, that's SW. So on the SW map, that's A bar, B bar, C bar, okay? So there's A bar, okay, here and here, and then a B bar, C bar is here. So we've got a 1 sitting here and a 1 sitting here for that term. Next term over here is on both maps. There's no SW, that's been eliminated. So that's A bar, B, C bar. So look, there's the A bar here and here, isn't it? And then I'm looking for the B, C bar. So I've really got this term here and this term here, and it's on both maps. Okay, next one is CO bar, A bar. So there's CO bar, A bar, and then it is BC. Okay, so it's sitting here on this map, and it's also sitting here on this map as well. Okay. Next term is A, B bar, C bar. So look, where is A true? A is true here. It's on both maps, but it's true here. And I'm looking for what? B bar, C bar. So that's a term here and here. It is on both maps, so I'll plot it here and here. All right, my last term here is what? It's CO bar A. So CO bar A is here. And I'm looking for what? B bar C, okay? So there's a B bar C here. So that's a CO bar A, and then it's a B bar C. So there's a B bar C here. So that term is there, okay? And it's also existing on that map as well, like so. All right, so what we're going to try to do now is minimize, and let's have a look at what we've got. All right. Don't think we're going to do a lot, but let's try. All right, so look, I could certainly group these guys together here. All right, there they are. Let's write down our expression then. Cn is equal to. Reading that off, okay, it's going to be on the SW map because it doesn't exist on the other map as well. So what is this? This is basically SW, and it is B bar, C bar. So that's a B bar, C bar. Or, let's see, what else can we grab here? Well, look, I could get basically these 2 guys here with these 2 guys over here. Let's see if we can read that off. Okay, it's on both maps. So reading that off, what do we have? Well, we have A, so that's right, A, and it is what? B bar, C bar. So that's a B bar and that's a C bar. All right, what else can we do? Well, look, I can grab these 2 with these 2 over here. So what do we have here? So it's on both maps. Let's read this off. So that's a CO, okay. In fact, it's a CO bar, A bar. And then what's common as I move in this direction here is what? It's just B, isn't it? Yep. Okay, what else? Well, let's use a different color just to make our life a little bit easier, okay? All right. Well, I could certainly grab this guy, and it also exists on the map here and here, so I've eliminated the SW, so this is an OR. Let's read off what that term is. Well, let's look this way. What's common? Let's see, it's A bar, isn't it? So that's A bar. And then what do we have as we look this way? We have a B, C bar. So that's a B, C bar term. Okay. All right, what have we got left? Well, we've got this guy left and this guy left, so our best grouping now would be really there and really there. And so that's another OR. And what do we read off? We've got basically CO bar, and that's an A, isn't it? And what do we have common over here? We have B bar as a common. Okay, so there is our reduced, somewhat, little bit reduced Boolean equation. Okay, we're going to take a break, and what I'd like you to do is see if you can write down the Boolean equations for the rest of these outputs over here, and see if you can minimize them as you go along. And we'll come back next time and work that together.